this is the next part of the the testing methodologies, which is called as the data flow testing. Okay, the name data flow testing is similar to name. I think you have heard of that is a data flow diagram, right? It is used in to depict the data that is being processed by different functions when softwares are designed, right? So it's like similar, but actually not exactly. Actually, though the name only is similar, but the concepts are a little bit different. It's not the same concept that you get in case of the data flow diagram. But here it is used for testing, where we consider the is a form it as a form of structural testing, okay, that focuses on points at which the variables receives the values and the point at which these values are used or referenced. Okay, so those lines of the code, see, it is about testing, whiteboard testing. Okay, so those lines of codes which receives certain values, because most of the applications in real world, they are basically data processing applications. Okay, so the points or the lines of codes where the variables actually receives the values. Okay, it may be through input console, it may be through assignment, whatever it is. They receive the values, the variable gets the values, and the lines where they are being used, okay, in different expressions, that to compute something, you use those data that has been received through the variables. Okay, and or in many situations where they are used or referenced. Okay, so those are the two structural bases which are considered to create the data flow testing methodology. Now we'll look into two mainline form of data flow testing. Okay, so one flow is the set of basic definitions and a unifying structure of test coverage matrix. Okay, it's basically we'll have a set of basic definitions according to which we'll identify the paths on which the data is being defined and used. Okay, and the other is based on concept of the program slice. Okay, we'll come to that later on. First we'll discuss the first part, that is we'll consider the data flow testing from two mainline forms. One is where we use the basic definitions, another is on the concept of program slice. Okay, first we'll discuss the methodology that will depend on the basic definitions, and then we'll move on to the program slice. Now data flow analysis often centered on the set of faults that are now known as defined reference anomalies. Now, which are the anomalies which are depicted with the data flow analysis, data flow testing? Is a variable is defined but never used. Okay, these are actually the primitive way of using the data flow testing methods. Okay, that is, if you have defined a variable somewhere in the program in a particular line and you have never used that variable, okay, that is likely to be identified through data flow testing methods. The variable that is used before it is defined. Okay, if you are using a variable before the particular variable is defined, that anomaly will be identified through the data flow testing methodology. A variable that is defined twice before it is used. Okay, suppose if you are defining a variable twice before the variable is used, that kind of anomaly will be identified through data flow testing. So these anomalies can be discovered by what is known as static analysis. Okay, so what is static analysis? That is finding faults in source code without executing it. Okay, so by identifying the data flow testing path, we will identify those faults which are in the source code but we are without executing the source code. Okay, that is when by analyzing only the source code lines, we will identify uh, those anomalies, okay, that are there in the program. The first basic definition is, given a program P and a set of variable V, suppose if there is a set of variable V and a program P, and you have a graph which is identified by GP, okay, then for every node that belongs to GP is, so what we have a program P, a graph G, okay. So a program graph is identified by the GP. We have a program P, we are going to create a graph G, okay. So it is basically a set of variable V, a set of variable V. We have a program P, we have a set of variable V, and a program graph which is identified by GP. That is program given as input. Actually we are creating the graph, that is the program flow graph, okay. That's how to create the program flow graph, we have already discussed earlier, okay. Then for every node that belongs to GP, there are two defining nodes. One is a defining node of variable V belongs to V, a defining node of the variable V belongs to V, written as DFVN. This is written as DF. Then you have the V, small v, and N. This particular node is defined as the DFVN if and only if the value of the variable V is defined at the statement fragment corresponding to node N, okay. So for that particular node, whatever the statement is representing by that particular node, the fragment of statement or the complete statement, whatever it is identified with that node, is basically defining that particular variable. Then we call this variable is as DFVN. That is where it can be through input console, reading through the input console, or it may be through assignment, okay. You are defining a variable. So that is called as the defining node, okay. Those kind of nodes which represent such statements where the variables are being defined are known as the defining node. Remember this, defining node, okay. There is another kind of node for every variable that is there in the program graph. That is usage node. Usage node of the variable V that belongs to V, capital V is the set, small v is the particular variable, instance of that particular set, okay. So written as USC, then Vn, the variable is basically part of a statement that is represented by the node N. Now if and only if the variable V is used at the statement fragment corresponding to node N, okay. If it is used in the statement fragment the corresponding to that node N, that means whatever statement is represented by the particular node, if it is being that particular variable is used there, then we call it as the use node, okay, and that is represented by this way, okay. So remember the defining node and use node, these are the most important part of this particular technique that we are going to discuss. Now one more definition, there are more definitions. Among the basic definition, one more definition is that the usage node is a predicate use. We call the usage node predicate use, and that particular predicate use is represented by P use if and only if statement N is a predicate statement, and otherwise we call the use Vn is a computation node, okay, and that is given by C use, okay. So we got this statement. Now we have the P use, okay, P hyphen use. P use is the usage node, okay, which indicates a predicate statement. And if the same usage node indicates a, otherwise, if it is not a predicate statement, it is called as the C use. Okay, C use. So, a particular usage node can be either of two categories, predicate node or the computation node. C use means computation node. If it is not a predicate use, that means the variable, if it is, when it is a usage node, that means the variable is used in that particular statement that is represented by that particular node, then the variable can be a part of either a predicate node or computation node. When it is a part of predicate node, when it is the part of the statement which represents either a loop condition or a if condition, else condition, such kind of node. So, when it is, which are called as the P use. P use are the nodes where the out degree is greater than equal to 2. Now, when the out degree is greater than equal to 2, when there is a decision in that particular node, okay. And the computation nodes are basically the nodes where the out degree is less than equal to 1. So, it is less than equal to 1 because the node can also be the end node, okay, the terminating node. So, out degree can be 0 also. So, it is, otherwise there is one out degree only. So, such kind of nodes are called as the computation uses, okay. Now, there is a definition use path which are called as the DU path. With respect to the variable B, is a path in the set of all paths in the P, which is represented by path P, such that for some variable V, small v, that belongs to the set B of variables, there are define and usage nodes such that M and N are initial and the final nodes of the path. That is, when we have a path which is called as the definition use path. When is called definition use path? When the initial node of that particular path is the defined node and the terminating node of that particular path is called as the use path, use node. Okay. So, when we have a particular variable defined by a node Vm, this one, and there is another node Vm, such that these two nodes M and N that are part of the, that is the define and the use, are actually the initial and the final nodes of that particular path. So, such path which starts the node M, which is the defined node, and ends with the node N, which is the use node, are called as the definition use path. So, such kind of structure are called as the DU path. What is DU path? Is definition use path. What is definition use path? That starts with the defined node, ends with the use node, N. So, such path, when we have, they are called as the DU path, define use path. Okay. There is another definition which is called as the define clear path or DC path. Okay. This is called DE path. We have another definition where we have which are called as the DC path. DC path means define clear path. So, define clear path is a definition use path in path P with initial and the final nodes are given by DF, VN. VM, M is the initial node, that is the defined node where the variable is defined, and where the N is the node where the variable is used, such that no other node in the path is a defining node of V. So, when we have such condition where no other node inside the path, in all the nodes that are been covered inside a path is defining that particular variable, but it is actually variable, it is defined only in the initial node that is given by DEFVM, and that ends with the use Vn, that is the node n, starts from node m and ends in node n. Okay, then such paths are called as the defined clear path. So you can say defined clear path is a special case of the DU path. Okay, that is the defined use path. The defined clear path is something like a special case of defined use path. Okay, so because with the condition that that particular variable should not be defined by any other nodes in the intermediate nodes in that particular path. That is the condition for defined clear path. Okay. Now let us analyze this entire structure, that is the data flow testing methodology, by using a particular problem which is called as the commission of Missouri. Now logs cost $45, the stocks cost $30, barrel cost $25. I am referring to as the example as it is given in the book, because we will be taking that as a case study to discuss these problems. Okay, so I am just, as it is given by the author of the book in a case study, I am just referring that way. Now the persons had to sell at least one log, one stock, one barrel. Okay, but not necessarily one complete rifle per month. Okay, so person has to sell at least, for every salesperson has to sell at least one log, one barrel, one stock per month. Okay, and production limits were such that the most of the salesperson could sell in a month was 70 logs, 80 stocks, and 90 barrels. Okay, so production such that the maximum limit for each salesperson can sell is 70 logs, 80 stocks, and 90 barrels. Okay, so these three components. After each town visit, they go from one town to another town. After each town visit, the salesperson sends a telegram to the Missouri gun person, that is the rifle maker, with the number of logs, stocks, and barrels sold in that town. So they visit one town at a time, and they, after selling, when he is moving out of that particular town, he sends a telegram to the rifle maker informing the person, the rifle maker, how many stocks, logs, stocks, and barrel the salesperson has sold. Okay. At the end of the month, the salesperson sent a very short telegram showing -1 log sold. So when the month ends, every salesperson sends a small telegram by showing the -1 only. -1. That means the selling assignment for the month has finished. So the rifle maker knows that the particular salesperson has finished selling the components. Now the commissions can be calculated. Okay. So the gunsmith then calculates the commission in a pattern that 10% of the sales up to $1,000. So up to $1,000, the rifle maker gives 10% commission to the salesperson. Above that, 15% on next $800. So another $800 for another $800, the commission calculated is at a 15% per component. And above that, the above 1800 is 20% per piece being sold. Okay. So for up to $1,000, the calculated commission is at 10%. From 1,000 to 1,800, the commission calculated is at 15%. And above 1,800, the commission calculated is at 20%. That is the simple formula. Now, this is what the program has to represent. Now, this is the program. Okay, this is the first part of the program. It doesn't come in the same slide, so I am dividing into two parts. Now here, you see the defined variable starts from the statement number 7, where the variables are assigned values. Those are the defined variables. So above that, up to 1 to 6, we are ignoring. Those are not important for us. Okay, because we are not assigning any values to the variables. So you can see the calculation process. Okay, there is a loop here. When it receives the my logs is -1 means commission starts calculating. So we have to, while not log is equal to -1, the loop will keep on executing. So input stocks and barrels, it will just keep on inputting the stocks and barrels, and then the total stocks is given by the loop. Okay, so the logs variable is used to calculate this one. So for every logs, the total, it will add it to total stock. So total logs, it will go on increasing. Similarly, total stocks will go on increasing, and total barrel will also go on increasing. So depending on all the logs, it will go on increasing the values as with 3 different values: total logs, total stock, total barrel. Okay. So output of the for each salesperson is identified by giving the output statement here. So this is the logs sold, total logs, stocks sold, total stocks, barrels sold, total barrels. Okay. The next part of the statement is actual calculation of the commission. So the log price into total logs gives you the log sale. Similarly, stock price into total stocks gives you the stock sale commission, stock sale amount. Similarly, barrel price into total barrels gives you the barrel sales. So then the total sale amount is calculated by adding these 3 components, and then the actual commission calculation comes in the if then else statement here. That is, if sale is greater than 1800, that is commission is 10% for 1000, because if it is greater than 1800 means up to $1000 the person will get 10% commission. So 10% into $1000 plus 15% into $800, because for next 800 he will get 15% at 15% interest, and above that he will get in the 20% interest. So for sale amount greater than $1800, all the 3 have to be considered to calculate the commission. Else means what? The sale amount is less than 1800. So if it is greater than 1000, then you calculate at 10% for $1000 and 15% for sales minus 1000. That is the additional amount above 1000. That is 1000 to 1800, in between the 1000 to 1800. Okay, in that $800 range. So that will be calculated at 15%. Okay, else means the person has sold below $1000 or maybe only $1000. So that will be in the 10% interest category. So 10% into sale. So that is how the amount is calculated. Now this is the program flow graph for that particular statement. Program flow graph, as you know, it starts from the 7th statement, because the defined statement starts at 7. Okay. So there are some decision statements, as you can see. The 14 is the decision statement, 20 is the decision statement, right? Similarly, 29 is the decision statement, 34 is decision statement. So these are all different decision statements, and 13 is also decision statement. So these statement numbers are given in the program itself. You can identify with the program statement, the statements inside the program, and then the graph. Okay, this is the program flow graph corresponding to the program statements that are given as in the program. So the numbers are given here. The same numbers are in the notes in the graph, in the program flow graph. Okay. Now, after this, select this is the primary component that you have to identify. Okay. Try to identify by every program flow graph the define use node. Okay. So it is done in terms of a table here. You can see the log price is defined in the statement 7 and used in the node 24. So the log price variable, you can see the program here, is defined in the statement number 7, and used in the 24. So that is where the log sales, that is log price into total logs, gives you the log sales amount. So that is where it is used. Okay, because you are using here that particular value that is defined. Similarly, you can see the total log is defined define is at 10 and 16 statement and use at the node 16, 21, 24. Okay. So total logs is defined in two places, 10 and 16. Let us see. The 10 total logs is assigned to 0. 16 total logs is equal to total logs plus logs. So gives you are reassigning a value. So it is also defining statement. Because you are also using the as the part of that particular statement to calculate. The commission node is basically the commission variable is used or defined in 31, 32, 33, 36, 37, 38. There are 6 different places where you are defining the commission variable and you are using the particular variable in the statements 32, 33, 37, 41. So there are 4 different places where you are using the commission. Okay. So these are all define and use nodes. Try to identify all the define and use nodes. Okay, because this is very important to identify the errors. If there are some errors that occur, you have to be. This is the first step that you have to do to generate the test cases for the program. Okay. So define / use path, that is the DU path for logs. Okay. So for the log, there are 4 DU paths which we are identifying. Okay. All are definition clear also. Both are DU path as well as DC path. Okay. Definition clear path also. Now, which are the defined use path here? P1, P2, P3, P4. See, let us see. See, these are in the next statement we are seeing here because we have identified it a separate component here for this particular logs. See, these are all part of this larger graph. Okay. So, but we are identifying this with a separate diagram here to identify that particular loop where the logs is defined and used. So, there are 4 parts, P1, P2, P3, P4. Okay. And the entire component where the logs is defined and used is given by this particular graph. These are basically subgraph of this graph and this graph is a subgraph of this graph. Okay. So it basically starts from 13 to this component. This one we are analyzing. 13, 14, 15, 16, 17, 18, 19, 20 back to 14. Okay. That is what we are using here to identify. Okay. Now the DU path 13 and 14, you see what is the DU path? As I told you, where the defined node is the starting node and the use node, there is a use node which is in which is the end node. Okay. So that starting from n to m, where a particular variable, a same variable is defined in that particular part and that ends in a particular node or use node. Okay. So for any variable v, if the node m where it is being defined and node n where it is being used, then m to n is the DU path. Now here you can see it is defined in 13, that is the input logs. Okay. That may end in 14 because that may be actually is equal to -1. Suppose the condition is not satisfied. So it will end there itself. So it is the logs will be assigned to this logs will become actually that will make it an end. So this first one is the 13, 14. Okay. When it does not enter the loop condition, it is going to end in that because there is another, you see the 13, 14 is a node where you have a separate path on that side. Okay. So after that you are not using that particular variable anymore. So that is the end node for that. It can be only 13 and 14. Okay, that is being used there. So similarly path P2 starts at 13. 13, see the statement here, 14 suppose where the log is not equal to -1. Okay. So it enters the loop. Okay. Then it gets the input stocks and variable. We are see, stocks and variables are two other variables for which you can have a separate DU path. So we are not discussing about the DU path of stocks and barrel. So we are just analyzing the DU path of logs. Okay. So it is 13, 14, 15, 16. Where it is being used? In 13 statement, 14 statement, in 15 statement and 16 statement. Okay. So logs is used in the 16 statement. So see, the 13, it is being defined in 13 and it is being used in, same variable is used in 16. Okay. After that you are not using. There is another input part at the node 19. So it makes a separate DU path because it is defined in 19. In the 20 is the while end while, and it goes back to the condition 14. So this makes a different DU path because it starts or defined in the 19 node and goes at ends in the 14 node. Okay. So similarly, we can have starting at the node 19, you can also go for, if the condition satisfies, it has to enter the node and 15 and 16. So it is like similar to the P2 path, only thing is that it starts at 19. So defined is that the variable is defined in the node 19 and used in the node 16, the last node 16 where it is being used. So this makes a separate DU path. Okay. So we have 4 DU paths, that is P1, P2, P3 and P4. I think you have understood. It should not be a very difficult to understood. It is a easy concept. Okay. If you have understood what is define and use nodes, you will understand this concept very easily. Okay. Test cases for define and use test cases. We can have the techniques for a particular variable. For every variable, we can have such, define the paths which will be created. Okay, DU path, and for all its find all its defining definition and use nodes. Okay, first you identify for a particular program all the definition and usage nodes. Okay, then you find the DU path and DC path among these variables. You identify the DU path and the DC path. For each path, devise a suitable set of test cases. Okay. So for every path that means the DU path. For every DU path, you identify a suitable set of test cases. Devise a suitable set of test cases. Definition clear is actually DC path is easier to test. So because it is not needed to check each definition node as is necessary for DU path. So to definition DC path is actually easier to check or using the test cases than the DU path because you don't have to check each definition node. Means methodology for white box testing. I think you have understood, right? So we'll have one more topic on this. It is not very difficult. It's also important because in case of those path testing, that other methods of path testing that we have discussed, like DD path testing, etc. So the coverage, every kind of error may not get detected, particularly related to those related to data, where multiple definitions are being assigned, or it may not, where you have used a particular data without defining it, etc. Okay, so only data flow testing is the only methodology which can detect such kind of error easily. And also the coverage of data flow testing methodology is better than those decision to decision testing coverage. Okay, so thank you, and if you have any doubt, you can ask me at any moment of time. Okay, so thank you.